Hey guys, welcome to my video. This is going to be on enzyme kinetics to clear up any confusion about enzymes and how they work. So let's start with, by the way, I'm using what's called Bamboo to use notes to like draw stuff out for you guys. So that's going to be how I draw stuff out on the computer for you. So today we're going to talk about enzyme kinetics. So let's first draw a graph, because whenever anyone thinks of enzyme kinetics, ultimately the first thing is graphs. So sorry, I'm kind of new at this. Just got this thing. Okay. So on the x-axis, we have the parameter known as substrate concentration. Whoops. Just S. So by the way, whenever you see this around something, it just means concentration of whatever it is that's in brackets. So that just means the concentration of S, and S is the substrate. Okay, so on the y-axis we have the velocity. Okay, so velocity is how fast the enzyme works. Its efficiency. Okay? So we'll talk about the important parameters in a second, but let's first draw out a typical graph. So let me use a different color. It's going to be a challenge. So you've probably seen something that looks a lot like this. I'm trying to draw that there. Okay, this right here is where it plateaus, is known as its maximum velocity. The maximum amount of turnover where it will go from substrate, remember S, into product. The fastest it can work is when its velocity is at its highest, right? Which makes sense. And this is called its Vmax. Sorry, I keep doing that. So its Vmax is represented is the quantity right here where it works at its highest. Okay? The other important value is seen, so let's say we give this number at the velocity is at 100. Okay? Is its max. Then half its max is 50. Okay? And at this point right here, switch colors. At this point is its Km. So the Km this is a confusing term for many students. The Km is the substrate concentration at 1/2 the maximum velocity. So remember, this is 1/2 Vmax, right? Because Vmax we know is 100, so 1/2 Vmax is just 50. So what the Km means is the substrate concentration, whatever the substrate concentration is at 1/2 maximum velocity. So let's say the numbers are, we'll deal with numbers later, but the value of Km is based on the substrate concentration at 1/2 Vmax. Okay, that's something important to remember. So let's clear this and we'll go make some more notes. Okay, so let's do an example. Okay, let's do it like this. Let's say this is just 0. Stop right here. Say this is 0. Okay? And then this is, say this is 25. Sorry, it's a little uneven. So let's do 1, 2, 3, 4. Change colors there, sorry. Still not really sure how to work this, but I promise I will work at it. 5, 6, 7, 8, 9, 10. Okay, so remember, x-axis, just label it x-axis, is the substrate concentration. This is the velocity. Okay? So now, this is, we'll say this one is enzyme A, and this is enzyme B. Okay? So the question, let's say the question 1 is, what is the Km of A? Okay, so how do you find the Km of A? So remember, the Km is going to be the substrate concentration at 1/2 Vmax. So ultimately, the units are going to be based on this. So let's say the units of this are millimoles. We know that we have to report our answer in millimoles, okay, of the substrate. So what you do is you go to you find Vmax of A first. Vmax of A looks to be about 90. Sorry, it's a little skewed. But if you draw it, it'll be about, let's say it's about 90. So take half of 90, which would be 45. So let's say it's about right here. Okay, so we first take 1/2 of Vmax, so 1/2 of 90, which is 45. So we come here, and then extrapolate it to the x-axis. That just means sorry, it's right here. Ignore these dots, because it's on this, we're looking at A. So 45, and then just come down. So what I did here, so this is, let's say this is about 0.5. That would be the Km of A. Millimoles. So all you do is you find half Vmax, 45, take that value, find where it is on the graph of your enzyme, and then find what substrate concentration it is for that value. Okay? So let's say question 2 is, which enzyme is more efficient? Efficiency just means which one is able to turn over more products from reactants, from substrate. Remember, it's all about substrate going to product. Okay? So which one does that better? Well, that's just the one with the highest Vmax, right? So this one, A, has higher Vmax, therefore a higher efficiency. Okay? Pretty simple. So I want to first look at something called inhibitors, because they can provide a lot of information about enzymes and are a topic of a lot of discussion in your classes. You're going to deal with them on exams. Teachers love to talk about inhibitors. There are 2 types: competitive inhibitors, I'm just going to shorten it with I, and non-competitive. Inhibitors. Okay? What's the difference between the 2? So for competitive, what happens is an enzyme, let's say so an enzyme is a protein, we know that. An enzyme just converts a substrate to product. That much is obvious. Okay? So an enzyme, we'll say it looks like this. Okay? And our product, and our substrate needs to fit into this little, what's called the active site. Active site, okay, is right here. It needs to physically conform to that site. Okay? God, I'm really sorry about that. I will fix that soon. I just want to get this message across. So, competitive inhibitors, what they do is they bind to this site. Oh, my pen seems to have... Okay, sorry about that. Competitive inhibitors bind to this site and prevent the substrate from binding. So what it looks like is you have your enzyme, right, with its active site, and competitive inhibitors block the site. They block the site so that no substrate can enter. Okay? Only if the substrate concentration is really high, is greater than the competitive inhibitor, which I'm just abbreviating CI. It's just CI. Only if the substrate concentrator is way greater than the competitive inhibitor does the substrate actually come in here. In other words, the substrate has to fight out the competitive inhibitor. They're competing for the same site. Okay? So we'll look at graphs for competitive inhibitors in the next video while I figure out how to work my pen.